I'm really happy to see many people in this room now, even though this is the morning session on the last day. And especially I see some really enthusiastic people in the front row. And in this session, I will talk a little bit practical aspect of machine learning projects. So if you are actually working on some real machine learning projects, I hope you will find something useful for your project in this session. Okay, anyway, I'm Etsuji Nakai. I'm a solutions architect for Google Cloud Platform. I'm based in Tokyo. And in this session, I will talk about the continuous deployment in machine learning. So what does it mean? The concept of continuous deployment is fairly common today, especially in the field of web applications. So for comparison, let's think about the very traditional enterprise business application project. In that case, once you have successfully launched your initial version of your business application, it is basically the end of the story. It's a really happy ending of your project. However, if this is a project of the modern web application, especially for consumer users, the situation is different. Because the requirement from end users, especially from consumer users, are always changing. So to keep up with the changing reality, you have to keep upgrading your application. Sometimes you have to introduce new technology to change your application completely. So basically, you have to keep deploying new versions of your application forever. This is a basic concept of continuous deployment in web applications. And I'd say the same concept can be or should be applied to machine learning project. So let me start with explaining what continuous deployment means in machine learning project. And this is a very common imagination about machine learning among many people. I don't say it's you, but still many people believe that machine learning is a magical mathematical algorithm. You have some data, you put those data into the algorithm, then you have magical result. Of course, it's illusion. As you know, the real machine learning project, especially the end-to-end process of machine learning, involves a lot of human efforts. First of all, you have to collect your training data and organize them with some big data tool, like BigQuery or Cloud Data Flow on GCP. And then you need to employ data scientists to build machine learning model according to your training data. And then you use a bunch of computing resources, like on Cloud Machine Learning Engine on GCP to train your machine learning model. And finally, you can deploy the trained model to the real world as an API service or as a backend service of your machine learning applications. And the good news is that you have a lot of useful tools to support this end-to-end machine learning process on GCP. And I think you have heard of these tools in other sessions. However, in this session, I don't talk about these tools at all. The main focus of this session is about feedback. Because the goal of machine learning is to predict something in the real world. And as you know, the real world is always changing. So you need to have some feedback from the real world to upgrade your machine learning model, to keep the freshness of your machine learning model. Now, the question is how and why feedback or the freshness is important in machine learning. So let me use this very simple example to explain why freshness matters in machine learning models. This is a tutorial article. The title is Machine Learning with Structured Data. I published this article this year, so you can find this article by searching with these titles. And in this article, I explained how you can build machine learning model to predict baby's weight. On the right side of the screen, you see an example application. You specify some attributes of pregnant person, and by clicking the predict button, you can make a prediction about the newborn babies' weight, babies who will be born in near future, like in 2018 or 2019. I think this model has some realistic use case. I believe some doctors can use this machine learning model for some medical purpose. But anyway, in this article, I used the open public dataset called natality dataset to train this machine learning model. It is available for everyone on BigQuery. It is birth records in the United States from 1969 to 2008, and it contains more than 100 million records. So in a sense, it is a big data. It contains data for nearly 40 years. Very good. But let's look at the snippet of the SQL to extract train data from BigQuery. As you can see the where clause, I didn't use the whole 40 years data to train this model. I used only data after 2001. So what's the problem with using the whole data to train this machine learning model? And the answer is data freshness. Because the goal of this model is, as I told you, to predict baby's weight who will be born in near future, in 2018. So naturally thinking, using fairly old data, like in 70s, to train this machine learning model may not be good for that purpose, because environment surrounding people in 70s could be totally different from today. So I did some experiment. First, I trained this machine learning model with the data in fairly old days, like in 70s. And then I tested it against the relatively new test data in 2008. And the result was 1.21 RMS error. What does it mean? It means the predictions of this model is different from the ground truth, different from the actual value, in average 1.21 pounds. Is it good or bad? Of course, to understand it, you have to compare. So then I trained the same model with relatively new data from 2001 to 2008, and again tested with the same test set in 2008. And the result was 1.05 RMS error. So obviously, this result is better than the previous one. That's the reason why I used data only after 2001 to train this machine learning model. Very good, makes sense? However, this is not the end of the story. Now suppose that I'm really serious about using this machine learning model in the real world. I want to provide this machine learning model to real doctors. In that case, I have to validate this machine learning model against the latest data, like in 2018. Unfortunately, the open natality dataset do not have the data in 2018, so I couldn't test it. But naturally thinking, because this model was trained with the data until 2008, the test result against 2018 test data might be worse than the previous one. So basically, if you are really serious about using machine learning model in the real world for the practical purposes, you have to keep collecting new data forever. And sometimes you have to retrain your machine learning model with the fresh data to keep the freshness of your machine learning model. So this is the basic idea of the continuous deployment in machine learning. And the next question is how you can apply this concept in your machine learning project. What is the standard process of continuous deployment in machine learning? What is the best practice? So, to explain that today, I prepared three user stories. And the first two stories are just imaginary one. You may think these are really unnatural situations. I admit it. But at least I hope through these imaginary stories, you will understand what is the standard process of applying continuous deployment and what is the value of continuous deployment in machine learning. And the last one is a real user story. Today, I'm really happy to invite Kazusa-san. He's working for BrainPad. It is a machine learning partner in Tokyo. He has a lot of experience of managing real machine learning projects. He will talk about his experience, how and why continuous deployment is very important in his project, how he applies the continuous deployment in his real project later. Okay, but anyway, let me start with imaginary story. And for this story, I prepared a fairly simple example application. It is a handwritten digital recognizer. You can draw some number on the white canvas, and by clicking the prediction button, the model recognizes what the number is. Very simple. And now suppose that there is an imaginary company. The CEO wants to release this application to the real world and make some money. Okay, and as I told you, we have two imaginary stories. The first one is fairly bad. They will make a silly mistake. However, the important thing is to understand why such a silly mistake had happened and how they could have avoided it by applying the continuous deployment. Okay, so let's start the first story. Please welcome the CEO of the imaginary company, Nori-san, on the stage.
Hi, nice to meet you, everyone. I'm Nori. So I've just started my new company, and I've created a super fancy app using machine learning model. But I have a problem. So I'm not sure how much data we should collect to train a machine learning model appropriately. So my team had worked very hard to correct the initial set of the training data. But I still don't know if it's enough or not. So I hired a funky wannabe data scientist. So it's Yabu. So fortunately, he had a brilliant idea to evaluate our machine learning model. So Yabu, please tell me the detail.
Hi everyone, my name is Yabu, and I'm funky wannabe data scientist. Sorry, funky wannabe data scientist. So, to make success in machine learning project, I've read super advanced machine learning textbook, and according to it, you need to split your data set to training data set and test set. You know? It's very simple. So first, you should train your machine learning model with training data set and validate your model, your test set, so that your machine learning model will not overfit to training data. Actually, I've already done it for you, and I got perfect result. We got 100% accuracy here. So this is super nice, right? And we should deploy this machine learning model as soon as possible to our application. So what do you think, Nori?
Oh my God, I can't believe it. So nice work, Yabu. So I don't have any reason not to release this application. Okay, let's launch it.
Okay, thank you, Nori-san and Yabu-san. You are good performers. Now, on surface, they did a very good job. They achieved a brilliant result, perfect accuracy. And of course, they made a mistake. So let me show you what would happen if they launched this application to the real world. Can you turn to the demonstration screen? Hello, can you turn to the demonstration? Okay. This is a handwritten digital recognizer they launched. So let me try. I drew number 0, make a prediction. Okay, it's working. Great. Let me try number 1. It's strange. Let me try number 2. Okay. it doesn't work. So I will tell you what had happened under the covers. So can you turn back to the presentation? Okay, this is the data they use to train their machine learning model and evaluate it. They have only zeros. So that's why that model recognizes everything as zeros, but at the same time, they achieve the perfect accuracy against this test set. Some of you may think this is very funny and realistic situation. It is partially correct and partially wrong. I can say that very similar thing could happen in the real machine learning project, as you know. Sometimes you think you have a lot of data to train machine learning model, especially very complex deep learning model appropriately, big data, great. And you achieve the very good accuracy against the test set. However, if those data do not reflect the real world, it doesn't make any sense. It doesn't work in the real world. So the question is how you can detect such a silly situation, how you can avoid it, how you can mitigate the situation. That is a continuous deployment. So to explain it and to make the scenario a little bit interesting, I would add some assumption. Now suppose that they keep collecting data every day. On the first day, day one, they have just zeros, unfortunately. But next day, they have zeros and ones. Next day, on the third day, day three, they have zeros, ones, and twos. So by keeping collecting new data every day, they come closer and closer to the reality. And on the last day, on day 10, they have the complete data set reflecting the real world completely. So based on this assumption, let's see the next good scenario. They will apply the concept of continuous deployment in your project and detect the problem. I will mitigate the problem. So now please welcome the CEO of the imaginary company, Nori-san, again on the stage.
Hi, nice to meet you, everyone. I'm Nori again. So I've started my new company again. I'll skip this part. So anyway, so fortunately, I could hire a super real data scientist this time. So it's Yabu again. So Yabu, what can you do for me this time? Please tell me the detail.
Hi everyone again. My name is Yabu, and this time I'm real data scientist. So to make our machine learning project success, I think we should several things to do to keep the quality of our machine learning model. So let me show you some critical action items here. So to make success in machine learning project, first you should define your criteria or threshold for your machine learning model. In this case, we can say we can use the threshold as our criteria and the 90% accuracy as a threshold. With such metric, we can check if the machine learning model works well or not, or good enough to deploy that to real application. And the second, we should keep collecting data so that we have more and more unbiased data set that reflect the real world. And the last but not least, we should keep monitoring the performance of the machine learning model so that we can determine the timing of the deployment and also retraining of the machine learning model. So today, to follow these action items, it's a bit difficult in real situation, but today I want to show you some pretty good dashboard that follow these action items. So can you change to the demo screen? Okay, this is the data panel of the dashboard. So first, let me train our machine learning model with trained dataset from day one. Since it will take some seconds to finish training, let me explain how to use dashboard. So now you can see the data set from day 1 to day 10. But since this is a demonstration setup, you can see all the data set now. But suppose that in real situation, the data should be added every day. And suppose that we are now on day 1. So this is the situation where we are training our machine learning model with latest data set. So now training has done, I think. Yes. So what is the next step? As Etsuji-san says, the next step is validate our machine learning model. So let's switch to the validation panel of the dashboard. Again, you can see all the data set. But suppose that this is a demonstration setup. So let's assume that we are on day 1. And the result is, okay, now 100% accuracy. So as we said, 90% accuracy as our threshold. This 100% accuracy is far beyond our threshold. So if you like, you can deploy your machine learning model to your application as an initial version. But you know, this 100% accuracy is sort of illusion. So can you guess what will happen if you validate day 1 machine learning model with test set from day 2? Let's see. As you expect, the accuracy is now going down to around 45%. So this is really bad and far below the threshold. So do you know why this happened? Yeah, maybe you already know. So in day 1 data set, there are only digit zeros, but day 2 data set contains not only zeros, but also ones. So that's why day 1 machine learning model doesn't work well on day 2 data set. So what should you do in next step? Yes, the next step is retraining your machine learning model. So now we are on the data panel and start retraining our machine learning model with training data set from day 2. Since it would take some seconds again, so this time let me explain how to use the deploy button here. So this deploy button lets you easily deploy your machine learning model to your application. So let's check how it works in application window here. So now we deployed a day 1 machine learning model. So this machine learning model can recognize digit 0, but as you may expect, this model cannot recognize digit 1, as like this. So now maybe, yeah, training is done. So what will happen if we click the deploy button on day 2, as you expect? So can you change to the, yes, thank you. So now the application starts to recognize digit 1. Ooh, yeah. So this deploy button allows you to not only deploy your machine learning model to your application, but also roll back the machine learning model to your application. So implementing this kind of button or command in your system is very feasible and practical when you are driving a real machine learning project. Anyway, we finished training the day 2 machine learning model. The next step is validating our machine learning model with latest test set. Okay, now validate our machine learning model with test set from day 2. Oh, okay. So now the accuracy is recovered from 45% to 99%. This is really great, and this accuracy is far beyond our threshold. So you can now redeploy your machine learning model to your application. But can you guess what will happen if we test this machine learning model with latest data set? So now suppose we are on day 3. So what will happen is the accuracy, accuracy again is going down to 67%. So in this case, you should again retrain your machine learning model with latest data set. Actually, in machine learning project, you should keep or continue this process forever until you shut down your application. Well, this is very simple example, but in summary, in real machine learning project, there are 3 critical action items. The first is defining threshold and criteria of your machine learning model. And the second is continuous data collection. And the third is continuous monitoring. With those action items help you to make success in machine learning project. Thank you. Back to Etsuji.
Okay, thank you, Abu-san. Okay, can you keep your screen on the demonstration? Okay, now they did a fairly good job using this demonstration dashboard. So let's look back what they have done. On day 1, they trained their machine learning model with the day 1 data and tested against the test set from the same day, the perfect result. And the next day, they tested again the same model with the latest test set from day 2, and they realized that they had some problem. The accuracy is very bad. But at least using this monitoring tool, they realized they had a problem, so they could take action to recover from it. They retrained their machine learning model with a new data set from day 2, and then they recovered accuracy to 99%, fairly good. And next day, they tested it again, the latest test set from day 3. The accuracy became worse again. However, they can retrain their machine learning model. So using this kind of monitoring dashboard, they could realize they had a problem. That's the value of this monitoring. So can you turn back to the presentation? As you can see, on the last day, day 10, they have 10 machine learning models, and they can test against 10 data sets from different days. There are 10 times 10 equals 100 combinations. So just for experiment, I clicked all the validation button and see the result. It looks a little bit complicated, but for example, let's look at the first row. Those numbers show the accuracy of the model from day 1. Apparently, the accuracy is going down straightforwardly. So if they didn't have this monitoring tool, what happens? If they kept using this machine learning model forever, it is a tragedy, disaster. So the lesson is, in a sense, fairly simple. If you don't have this kind of monitoring tool, if you don't update your machine learning model with fresh data, your model will be obsolete, definitely. And you can learn one more interesting thing with these numbers. Let's look at the numbers on the diagonal line. This shows the recovered accuracy. First day, they achieved the perfect result. Next day, they recovered the accuracy to 99%. On third day, they recovered the accuracy to 98%. Interestingly, this recovered accuracy is also slightly decreasing. It looks like this on the bar chart. And as you remember, perhaps, he said that he set the 9% accuracy as a threshold. It means they don't want to use a machine learning model if the accuracy is less than 90%. In that sense, they have a problem on the last day, day 10. The recovered accuracy on day 10 is slightly less than 90%. It's a problem for them. They have to do something to recover from this situation. So let me explain first why this slight decreasing had happened. It is the data complexity. As you know, every day they keep collecting new data. They have more and more complex data. And if their initial model was very simple, it could handle the very simple first day data. But it may be really hard for the simple model to deal with very complex data on the last day. So basically, what they have to do is just redesign their machine learning model. If they are using neural network, they would add some more layers to make their machine learning model more complex to deal with more complex data. So this is a summary of the flow. On the top left, first you build your machine learning model and train with the initial data, and you keep monitoring every day or every week. And if necessary, you retrain your machine learning model, and sometimes you recover the accuracy above the threshold. And sometimes you cannot recover the accuracy even after the retraining. In that case, it is a really good timing for your project to redesign your machine learning model. You hire the real data scientists again. They will do some investigation about the nature of the current data set. They will redesign the machine learning model according to the current data set. Okay, now I think you have some basic idea what is the process of the continuous deployment. And finally, I will invite Kazusa-san from a machine learning partner in Tokyo. He will tell you his real experience, how he applied the continuous deployment in his real project. Please welcome Kazusa-san on the stage.
Hi, good to see you. I'm Kazu from BrainPad, which is a GCP partner in Japan. We have more than 80 data scientists in Tokyo, and we have delivered memory systems in a wide variety of industry for more than 10 years. Okay. One of our customer case of QP was featured in Google Cloud Next 17. QP is a manufacturer of food products, and their mayonnaise are very popular in many countries. They applied machine learning technology to detect bad potato cubes in their production line. We implemented that system with TensorFlow for them. Okay, let's come back to the main topic of this session. I'd like to talk about another customer case where we implemented continuous deployment for machine learning systems. I'd like to explain why the continuous deployment is so important for ML models. Unfortunately, the details of this customer case are confidential, so I will tell some essential aspects of continuous deployment, what I learned from this real case. The customer is the logistics service provider. They deliver clients' products from their warehouses to client outlet. So we helped them to apply data science and machine learning to optimize their delivery route and minimize their delivery cost. Here is our solution. First, we implemented a machine learning model which generates demand forecast for each product using the data from their CRM systems. And then we apply another model which calculates the best delivery route based on this demand forecast. Okay, due to this system, our client saves about $2 million per year. So let's focus on the continuous deployment of this demand forecast model. The diagram shows that the continuous deployment system in our client's case. First, we retrain the model in a weekly basis. Due to the change in the market, it is not possible to use the same model more than a week. So we introduced the retraining process in a regular basis. Sometimes the performance model is under the threshold even after retraining. In such a situation, our ML engineers try to modify the model itself to keep the model performance well. We generate a kind of a monthly report which is about model performance, so our client can understand what we are doing. Okay, this is the process of this continuous deployment in our clients. And then see some details. As Etsuji explained, the freshness of the data is very important to keep the model performance well. In this client case, the CRM data has a very strong seasonality and is influenced by some other external events. So the retraining with fresh data is a very good way to keep up with these changes. It is also important to monitor the model performance by comparing demand forecast and actual result. In most cases, in my experience, this retraining process works very well, so it would be a good idea to automate these repeatable processes, but sometimes it doesn't work. Even after retraining, the model performance could be very bad. In such a situation, ML engineers look into the original CRM data and other data sources to find out what's happening in the real market. Typically, this kind of performance degradation is caused by drastic change in the input data. It is influenced by, competitors' promotion or new product launch and so on. After finding root causes about this degradation, ML engineers think about how they can modify the model features to keep up with these changes. As you can imagine, this investigation is very hard to standardize. But at least we are building a dashboard to help ML engineers to work on this investigation efficiently. Finally, let me talk about risk management. One of the apparent risks in this process is that there is no guarantee that ML engineer can recover the model performance in a timely manner. There might be a data collapse in our data pipeline, and the model cannot make meaningful prediction for a while. This is a sort of nightmare scenario, and we should have a backup plan for such a situation. In this client case, we defined kind of a fallback plan with clients in a very early stage of this project. If ML model doesn't work at all, our client switch back to the manual operation. Of course, in this operation, there is no machine learning model. And then, our clients are using demand forecast, which is from human planner. And then he used the statistical approach to make this demand forecast. Okay, this is what I want to talk. And then I will talk and I will note that the customer case of this case are very simplified. Actually, in my project, we have much more complex process and metrics. But anyway, the most important thing in production environment is that how quickly we can detect this kind of performance degradation and how quickly we can fix it. We are now planning building a general platform to help ML engineer. Of course, streamline this kind of processes, including monitoring and retraining, redesign the model, and deployment. So I will hope this platform will be used in many machine learning projects for our clients. Thank you.
Thank you, Kazusa-san. Okay, so through his real experience, I think you have some realistic image what is a continuous deployment in the real project. So now, as a summary, let me talk a little bit about the platform for the continuous deployment. As Kazusa-san told us, he's now thinking about designing some standardized platform or general platform for the end-to-end machine learning, including the continuous deployment process. And I think this is really the frontier of the machine learning project. some customers and partners are realizing the importance of the continuous deployment. And most of them are thinking about what is the best practice, what is the best platform to support that process. And we, Google, is the same. Recently, we released a paper called TFX. It is an end-to-end machine learning platform used by Google internally, including the continuous deployment. Some of our machine learning services are actually running on this platform. Unfortunately, this platform itself is not an external service. You cannot use this platform as a GCP service. But at least the good news is that some essential components used in this TFX is available as a part of TensorFlow. You can see this paper for details. So in theory, you can combine TensorFlow with some standard GCP products and components to build your own continuous deployment platform. And for today's demonstration, I combined TensorFlow with some standard GCP components to build that demonstration dashboard. However, please be careful. These specific components are not important. These are just for the sake of demonstration, especially depending on the requirement of your project, functional or non-functional requirements. These components could be different. The important thing is to understand the general framework. And I think most end-to-end machine learning platform now has 3 components on the bottom side of this chart. First, you need some data platform to collect the trained data from the business data pipeline. And then you have some training platform like Cloud Machine Learning Engine to train your model with these training data. And finally, you have some serving platform to deploy the trained machine learning model to the real world. However, to realize the continuous deployment practice, you need one additional component. That is a validation platform on the top side. With this validation platform, you keep monitoring the accuracy of your machine learning model. And ideally, this platform has some visualization tool. With this visualization, you can understand the trend of the accuracy of your machine learning model, and then figure out the best timing to retrain your machine learning model or to redesign your machine learning model by hiring data scientists again. And also, it should have some automation mechanism, like today's demonstration. Just with a single click, you can retrain your machine learning model. With just a single click, you can redeploy your machine learning model to the real world. So this is a sort of call for action. If you're now working on some realistic, real machine learning project and want to apply the continuous deployment in your project, please let's start have a discussion with your team members to think about what is the most important feature in your continuous deployment platform. What is the best monitoring dashboard for your project? Okay, in that sense, I want to ask one additional question to Kazusa-san. Kazusa-san, are you still here? Thank you. Okay, my question is that he told us that now he's planning to design his own machine learning platform, including the continuous deployment for customers of his company. So what do you think is the most important feature of the machine learning platform for your customers?
Okay, the question is a little bit complex for me, so I'd like to answer this question in Japanese.
Okay, no problem. I will translate.
機械学習モデルを実際に業務で使おうと思ったら、その業務の中でどう、機械学習モデルを運用するかを考えることが一番重要です。一番重要なのは多分、評価の指標だったりとか、その評価のタイミング、そしてそれを実現するためのデータのパイプラインっていう っていうものを、業務の運用の中で考えないといけないと。なので、プラットフォームの機能として一番重要なのは、業務のプラットフォーム、業務フロー、業務アプリケーションとどのように連携して、機械学習モデルをモニタリングする、自動化するっていうことを考えないといけないというのが、それを実現するような機能っていうのが重要かなというふうに思います。Sorry about my Japanese.
Okay, that's no problem. I think he talked a really important topic, so it's really my challenge to translate it accurately. Okay, basically he told me that the most important thing in machine learning project is to evaluate the performance of the model in a real business context using the real business data. It means in today's demonstration, we simply tested the trained model against the test set. But in his project, as he talked in his presentation, he compared the actual business output against the model's predictions. So for that, he needs to combine the business data pipeline with a machine learning pipeline because he needs a very fresh business outcome data. It doesn't make any sense if he evaluates the performance weeks or months later. Ideally, he must evaluate the result in real time with the real-time business data. So the challenge is how to combine these two platforms, business platform and machine learning platform. So his idea is he wants his platform be capable of integrated with business data pipeline, with a machine learning pipeline. I think now it is a very common understanding that synchronizing business data with machine learning to collect training data in a timely manner is very important. But he told me that it is also important to synchronize the evaluation data from the business data platform. Okay, that's really a good lesson. Thank you very much, Kazusa-san. Okay, yeah, it's surprising. I really learned a new thing in this presentation from Kazusa-san. And I think it is really useful for your project too. And unfortunately, I don't have much time to talk about details, more details in a Q&A session. But basically, I'm really happy to have further discussion in person with you if you really like. So this is announcement. Today's afternoon, we have an event called Cloud Hero. This is a sort of DevOps competition. I'm not sure whether you can still register in this event or not, but at least I will be there. I will be attending this event. So if you want to talk to me in person, please find me at the venue of this event in this afternoon. Okay, that's all. Thank you very much.